V1. Rotate.
Hello ladies and gentlemen, and welcome back to another Flight Sim 008 video. Today, we're going to be starting a little mini-series on my favorite aircraft. Recently, PMDG announced their 747 V3 was going into beta testing. And to get myself ready for her, I've been studying away at the various systems of this giant bird. I'm not exactly sure how many parts this is going to end up being, but what I do know is part 1 will focus on the electrical and air conditioning systems. We're using the iFly 747-400 Service Pack 1 Alpha in Lufthansa colors. And besides the rather high VAS usage, it represents all the systems very well. So without further ado, let's jump into the flight deck and get started. First thing I'd actually like to talk about is the electrical systems. The electrical panel is located on the left-hand side of the overhead panel. The aircraft is equipped with 4 engine-driven AC power generators, as well as 2 APU AC gens and 2 external AC power ports. DC power is provided by 4 transformers, as well as a main battery and an APU battery. One thing not particularly depicted in this diagram is the Synchronous Bus, which is up where this line here is. It basically allows the buses to be operated at the same time. We'll get back to that in a bit. The electrical system is managed automatically. I say that in air quotes because most of the behind-the-scenes power switching is automatic, but the pilots must configure the system to do so, because pilots love switches and buttons, so Boeing installed a whole bunch to play with. Okay, so the diagram overlaid on the overhead panel depicts AC power flow. So each engine is equipped with an IDG, or Integrated Drive Generator, which is basically just the generator and the drive unit as a whole. And that's what we're looking at here towards the bottom. The drive disk guarded switches should, during normal operation, always be on, closed, and guarded. If they are disconnected during flight, they cannot be reconnected. The gen control switches in the on position allows the breaker to close automatically once the voltage is acceptable. Currently the engine gens aren't producing any power, but when we fire up the engines and power is being produced by the IDGs, the breakers will automatically close and switch over from our APU buses. A bus tie switch connects each bus to that synchronous bus we talked about earlier. They'll automatically open or close when in the auto position. Okay, so on the ground, the AC power is provided by 1 or 2 APU gens, or 1 or 2 external power sources. Back to that synchronous bus for a second. There's actually a split system breaker in the middle of the synchronous bus that can open and close automatically, depending on how many auxiliary power sources are connected. So when one source is selected, the breaker closes and powers both sides of the synchronous bus. And if both sources are selected, then the breaker opens and isolates the right-hand side from the left-hand side. The thing to note is that the sources cannot be paralleled. Basically, you must choose either external power or APU gens. Pressing one will cancel the other. Still with me? Okay, let's move on to the utility buses. There are actually 4 utility buses on the 747, and they're controlled by the left and right utility bus switches. The utility buses provide electrical power to crew rest lighting, air conditioning, lavs, more importantly, galley power, fuel boost pumps, fuel override and jettison pumps, and electrical outlets. The DC power system is really fully automatic, and each AC bus powers a DC transformer, which provides DC power to its respective DC bus. Yeah, electrical wizardry. Final thing to discuss is the standby power system. The 3-position switch in the top left corner of the electrical panel controls the source of standby power. Auto is the normal position for this switch. Normally, AC bus 3 powers the main standby power bus. If, such as in our case right now, AC bus 3 is unpowered, then the ground service bus provides the power. So basically our ground power is feeding the ground service bus, which is powering the battery charger. Without any other source of power, there's at least 30 minutes of standby power off the batteries. And I actually noticed that the SSB, or split system breaker, is actually depicted on the ICAS electrical system page. So if we were to disconnect external power 2, there you go. External power 1 is now providing, well, there you go, is now powering all of the utility buses. If we were to reconnect external power 2, the SSB opens, and we have isolation of the left-hand side and the right-hand side. Right, let's talk about air conditioning. The controls for the air conditioning system are on the overhead on the bottom right. Air is provided from the source to 3 air conditioning packs. These packs provide air conditioning to the crew and passenger compartments, as well as the forward and rear cargo holds. There are 2 pack controllers, A and B. In the norm position, they are alternated automatically from one flight to the next. Redundancy, yay! But each pack can be set to use a specific pack controller if desired. If that particular pack controller malfunctions, then the other one is automatically selected, overriding the choice on the switch. Pack 1 provides conditioned air to the main deck cabin, the upper deck cabin, and the flight deck. Pack 2 provides air conditioning to these same areas, as well as the rear cargo hold. And Pack 3, same passenger, and the forward deck, lower deck cargo hold. But it's not quite that simple. I'm going to have to put a little asterisk here because there's another switch we need to talk about. And that is the lower lobe cargo condition airflow rate selector. What a sexy name for a switch. The lower lobe cargo condition airflow rate selector, hang on, I'll find it, is located way at the top of the overhead here. There we go. Basically, in the off position, none of Pack 2 or 3's air is going to condition the air in the lower lobe cargo decks. In the forward high position, then all of Pack 3's air is going to provide air conditioning to the lower forward lobe cargo deck. In the aft high position, then all of Pack 2's air is going to the aft lower lobe cargo deck. So basically, in this position, Pack 2 is only serving to condition the air in the rear compartment, the rear cargo compartment. In this position, all of Pack 3's air is going to condition the air in the forward cargo hold. In the low position, the forward low position, then Pack 3's air is going to both the main cabin, upper deck cabin, and all that good stuff, plus the forward cargo hold. Aft, we've got Pack 2. 2's air is split into going to the main deck cabin and the rear cargo hold. And in both, we've got Packs 2 and 3 working in conjunction with Pack 1 to air condition the entire cabin, plus the air from Pack 2 is going to the rear cargo hold, and Pack 3's air is going to the forward cargo hold. Right, back to the main air conditioning panel on the overhead. I'm going to go ahead and connect an external air source, and we're going to open up the ICAS on the air conditioning page. There we go. So now you can see that we have external air connected. We're going to open up the isolation valves. Same thing as a 737, the right side and the left side can be isolated. With those isolation valves open, we get duct pressure in both sides, and now we need to direct that duct pressure towards our packs. Turning them on, you can start to hear that airflow all over the cabin, and we can see that the controller A has been selected for this flight. If we wanted to select B, the B controller, we could do that for each one of these. Remember, if one fails, it automatically selects the other. Okay, so we've got that. The other thing to point out is the purple, or the magenta, and the white indication here for the flight deck, the upper deck, and the various compartments in the lower deck passenger compartments. The magenta is the selected temperature, and the white is the current temperature. Now, we've got two selectors up here for the temperature. We've got the passenger and the flight deck. In the auto position, 24 degrees centigrade is selected, but we can put that into the manual mode, and we can go anywhere from, I believe it's 18 degrees centigrade, all the way up to 29 degrees centigrade, like so. I generally just leave it in the auto position. What's actually supposed to happen with these switches is if you take it into auto, they're spring-loaded to go into manual towards the bottom here, and then you can select manually whichever temperature you desire. So again, the magenta is what is commanded, and the white is what is actual. And the master is 24. Another thing to note is this button here, the trim air. Trim air is actually directly bleed air, which is warm air, which is introduced into the air conditioning system in order to provide that warmer temperature. So without trim air, you're going to see the system fault on the zone reset here, because the system cannot heat the air without any trim air. Trim air is the hot air that it uses to regulate that temperature. So that's why we turn the trim air on. The upper and lower Recirc fans are basically to use to recirculate the air already in the cabin, so as not to use all of the bleed air or all of the pack air in order to pressurize the cabin or to maintain its comfort level. We're basically just recirculating some of that air as well. The Aft Cargo Heat is what it says on the tin. It is the Aft Cargo Heat. The high flow basically turns on the cranks up the packs to 11, or the fans at least. You can hear the auditory difference. The pack reset is if we have a zone fault, then we would click on the pack reset and they will reset themselves. They'll turn back off, turn back on again, just like you would do with a PC first thing if it starts misbehaving. The gasper is basically taking air from this system and ducting it through to the you know those little fans that you get, or the little nubs that you get on top of on the overhead of your seat as a passenger that provide a little bit of extra air if you want to turn them on. Well, that's what the gasper does. It provides air to the passenger comfort systems. And the humidifier, same thing. It is what it says on the tin. It provides it recirculates some of that humidity instead of turning it to the evaporator, basically hopefully making the air a little bit more humid than basically just using conditioned and bleed air. So just to reiterate, Pack 1, most of the livable area inside the 747. Pack 3, livable area and forward lower cargo. Pack 2, livable area and rear cargo. And the trim air basically gets cut into the middle here, like so, and like so. And this is turning out to be much more horribly complicated than I thought it would be. And so the trim air takes the hot bleed air and uses that to regulate the cabin temperature. The last thing we'll cover briefly is pressurization. Pressurization is automatically controlled based on information from the FMCs. The only thing that, well, there's a full manual control system here to control the outflow valves, which we can open and close, and we can select manual for the left or the right hand side. And we have automatic landing altitude is also selected by information based off the FMC. We can, however, manually select the landing altitude. Let me just bring up the upper ICAS. And we can go ahead and press the landing altitude manual button. And there we have on the bottom landing altitude 2000. We can set it to whatever we want here. And it'll tell you your delta pressure, the rate, if it's climbing or descending, and the cabin altitude at the moment, as well as the duct pressure. Pressing it again, goes away, puts it back into auto mode. And that concludes the air conditioning pack and pressurization system on the 747 passenger model.